The two steps that we're not going to look at today are saving the weights of the model. So there are a few file formats in which you could save the parameters of the model, like CSV. There's one called H5. And another thing we won't be looking at in this course is deploying the machine learning model. So go to something like AWS or Google Cloud and deploying this. Depending on the model or library, I should say, you may have to go into something like Compute Engine or an EC2 instance on AWS. And then you would need to use Docker to download the image and create a container. So it will go into more of MLOps. That's what it takes to deploy a machine learning model. In other cases, if you're using a library like TensorFlow on Google Cloud specifically, you can just upload the script and Google Cloud will take care of preparing the environment. And by environment, I mean installing an operating system on the hardware, installing the right version of Python, installing the library dependencies. Let's switch then now until this is cooking in the background, and talk about activation functions. First, let's talk about ReLU, and then let's talk about softmax. So this is a very simple neural network. So this is this line of code here. Now, of course, for the input, we don't have a tensor. The input for this network is only 2 features. And the dense is 3. So we have 3 outputs. Okay, let's see. Now, we said that neural networks are matrices, but this is a graphic representation. I also have a matrix representation up here. Let me see if this one has the activation. This one does have the activation, yes. This is actually what a neural network is doing. So let me show you the graph representation, and then we'll look at the matrix. Since we've already covered, matrix multiplication, we can talk about this. Let me come up here. So let's say we have, I will use again the real estate example. And let's say this is a very simple classification model. So we want to classify a property by its category. So for example, is it a warehouse or is it an apartment, a residential apartment? Or let's say commercial property like an office space in a building, or apartment, residential apartment. So how are they different? You can have 2 properties that are similar in size, but with offices, you have less partitioning. You have fewer doors because you don't have any rooms, no kitchen. Maybe you have a kitchen. You don't have a balcony. And maybe it's just, what's the word I'm looking for? More open. Like there are no enclosing. There are no partitioning, essentially. So let's say I1 is the number of rooms in the property, and number 2 is the size of the property. Exactly, Ron. Open floor plan. Open floor plan. So obviously there's more things that we could describe to distinguish these 2. But again, the point here is to understand what an activation is. And this is the context of ReLU. I1 is the number of rooms. I2 is the size of the property. And we have 3 perceptrons in our 1 hidden layer. So this is 1 hidden layer. 1 input, 1 hidden, 1 output. What comes out of this output layer is the classification. Is it type 1 a property or is it type 2 property? Okay, let's see how this is done. So what we do is if you look at these arrows that stem from, for example, I2 will send to every perceptron its value. However, it is not just sending the feature, it is also sending a random weight and a different weight to each perceptron. So for example, the first perceptron might get a weight of 5. The second perceptron may get a weight of 1. And the third perceptron may get a weight of 10. So one perceptron will consider the feature to be somewhat important, another one not so important, and another one very important. And then we do the same thing with the first feature. We send the value to all 3 perceptrons, but we associate it with different weights. That's what the slide is about. So this is nothing more than some arithmetic. So here we can see we have the feature multiplied by its random weight. We have the second feature. And of course, all of this arithmetic is happening inside the perceptron. That's why you have this summation or this sigma. Sigma represents summation. Anyway, we multiply each feature by its random weight. So we only have 2 features here. And since this is for the first perceptron, we'll multiply it by its weight. And then we have the sum of the products. So let's say that this sum is 32. We will then take this number 32 and pass it to the activation function. This Greek letter phi represents the activation function. What is this activation function? Well, it depends. It depends on what you use for your layer. These are the activation functions you can choose. So this is the rectified linear unit. For the others, I'll take you to the playground to talk about this. Now, for any layer except the output layer, you never want to use a linear activation function, or here as it's known as the identity function, because, well, let me tell you how ReLU works, and then you'll see why you don't want to use a linear function.